quotient rule. So we just looked at the product rule when we want to find the derivative when we have two functions of x multiplied by each other. But now we're going to look what happens when we have two functions of x that are divided with one another. So let's have a look at y equals x cubed over x plus 1. So here we have two functions of x that are being divided by one another, and here we're going to need the quotient rule. So the quotient rule states that if we have two functions that are divided by one another, let's say u and v, the derivative dy dx is going to be u dash v minus v dash u over v squared, where the dashes are for derivatives. So let's go ahead and apply that to our function. So we're going to call the numerator u and the denominator v, and it needs to be in that order. And we'll write them separately, like we did for the product rule. So u is x cubed, v is x plus 1. So u dash is the derivative, so that'll be 3x squared. V dash, well, that's just going to be 1. The derivative of x is just 1. And now we can go ahead and sub it into our formula for the quotient rule. So our derivative, dy dx, is going to be u dash, which is 3x squared, times v, which is x plus 1. You'll notice how I put in a bracket, very important. Minus v dash, which is 1, times u, which is x cubed, all over v squared. V is x plus 1, and we need to square the whole thing like that. So we can tidy it up a little bit, saying we'll get 3x squared outside of x plus 1 minus x cubed all over x plus 1 squared. We can factorize a little bit out of the numerator, taking x squared out as a common factor. That'll leave us with 3 outside of x plus 1 minus x all over x plus 1 squared. We can tidy up the bracket in the numerator. So we get x squared outside of 3x plus 3 minus x over x plus 1 squared, and a little bit more tidying up. So 3x minus x is 2x plus 3 over x plus 1 squared as our final answer for the derivative. And you have to use the quotient rule when both your numerator and denominator are both in terms of x or some other variable.